Right, hello. This is the second video in this series about how I make a strategy game for PC in C++. There were tons and tons of views and comments on the first one, and they were very positive and they're very good and massively appreciated. I really didn't know whether like just half a dozen people would watch it, or apparently like almost 9,000 so far. So and it was really good. Thank you for all the comments and all the kind of encouragement for it, because like I say, if you're writing your own engine and developing a game in 2025 and you're not using Unity, then you kind of feel like an outsider. So it's good to know that people are interested in it. And I'm just going to say again, like I said at the beginning of the previous video, that this is how I make games. It doesn't mean it's the way or the only way. Obviously, loads of people use Unity, loads of people use C#. Whatever, do whatever you think is best for you. This is the way I do it, and I've been making games for, I don't know, I mean, it's more than 30 years, and I've been coding for 45 years. And I've sold like, I don't know, 6 million, 7 million games, I don't know. So it works for me, but you know, I'm not saying this is the only way. So that's the intro. So one of the things I thought I'd talk about is this thing that I think a lot of people whose only experience of game development, especially on YouTube, has been Unity, don't understand, or just never had it explained to them. And that is how you start. And anecdote warning, I once worked for a big games company, and I'd been there a little while, and they said, oh, we need you to make a tool to do some art processing stuff. And I was like, okay, yeah, cool. Because they always give the tools programming to the new people, because people hate it generally. I don't. And I said, oh, is there like a default project I should, you know, load up to create a new tool? And they said to me, just copy the game and then just remove all the game bits. That's what we do. And I was kind of a little bit shocked, because I'd made a bunch of games myself from scratch. And I thought, really not that hard to start from scratch. But anyway, whatever. But the reason I tell this anecdote is that a lot of people don't know how to start. And if you use Unity or you use Unreal, you start a new project and it's like a 3D world full of stuff. And you're probably thinking, where does it start? Where's the code? How does the program do anything? You can add stuff to your game. You can make a game like that, right? But most people don't know where they start. So I'm going to talk about how you start, because it's a lot easier than people think. So if you buy a book or do a course on like teach yourself C++ or C, they talk about a function called main, and that's where the program starts. So basically, if you know, if you launch an executable, an exe, it's the entry point, as they say. They're looking in the code for a very specific function called main. You can't call another global function main. It's not going to work. There can be only one. And that takes in the command line that you pass to the program, and that's where it starts. Now you can build an entire massively complicated object-oriented mega program from there on, but you definitely start with main. Now Windows is slightly different in that it has a function called WinMain, which is what we're looking at here. I think, yeah, I don't need to zoom in, do I? And it's not that big. You can see it there. So that's like the whole thing. I'll move this down because we don't really need to see all my debug nonsense, do we? And although it looks like a lot of stuff's going on, a lot of it's nonsense, right? So you have a function called WinMain. It has this special calling convention API entry, and it returns an integer. That integer that is returned is basically the error code from your program. So I can't even remember how this stuff works. Yeah, it's the last message that I'm passing back. Yeah, okay, whatever. But it's a very simple thing, but it seems a little bit arcane if you don't know anything about it, because it passes in these things, these handles to instances, which is like an operating system thing. This is this H instance stuff. This is the current instance and the previous instance. Sometimes you need that handle, and that handle is basically a number, and it's saying this is how we know your program, and it'll be used later. Okay. And you get sent the previous, I don't know what that's about, but you just get sent it, you ignore it. But you get the command line. This is a horrible Windows notation string, but it's basically the command line that you pass to your program that you can set in like Steam options and everything, blah, blah, blah. I don't use command line stuff really, because I think it's a bit out of date. And if you want to create a Windows program and go, hey, I coded a Windows program from scratch, you can stop there. You don't need to return 0, whatever. That's it. That's a Windows program. It will compile, it will run and everything. Pre-flight check is a little thing I do. You can see up here it's empty, right? This is just a thing that if I want to process something like some little tool or something that I want to do, and I just need to process some files or something, I'll stick it in there, and then I can launch my app. It does my little bit of code I wanted to do and then quits. It's just, it's pointless, but like I use this thing. The only other time that I would ever use it is if I was doing a demo of my game that I wanted to be time limited or something, and it would just check the date, and if the date's beyond the expiry date of the demo, I'd return, so the whole game wouldn't run. I know you can hack that, but whatever. Anyway, that's what that is. It's kind of ignore it, right? So I'm going to talk through in basic terms what this function does. Okay. Firstly, it initializes the application. I have a function called InitApp. I'll show it to you later, and it does everything that needs to be done once. Okay, so it would be like create the graphics engine. I don't care how many skirmish battles you play in Ridiculous Space Battles. I only need to create the graphics engine once, so I'll do it there. So I have like an initialization thing here, right? I set a couple of flags which I'm going to use later, but they're not important. But the rest of it is a loop. Okay, so this is kind of your game loop, but this is like Windows processing version of a game loop, right? And what it does is it looks for a message that is applicable to this program. If there is one, it gets it. It does some stuff with it, and then we run our normal game loop. Okay, so my actual game loop that does all the exciting stuff is here. Okay, but what we first do is we need to check for messages, and you can see that while one is just a way of having an infinite loop. Okay, so I can kind of not get out of this, as it were. In fact, how do I ever trigger this? Because I definitely do. Blah 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 blah. Anyways, I'm not going to get distracted. I'm going to try and explain my code, but not bits I've forgotten how they work. Yeah, so this loop. Okay, basically, Windows is it's like an event-driven operating system, right? So Windows doesn't do stuff. What Windows does is it sits there and responds to messages, and every window on your PC is getting loads of messages. Windows generates all these messages. So a message might be, we're clicking a mouse, we're clicking a key, the time has changed, whatever. And it sends those messages out to all the applications that are running. And you get the ones that are either deliberately sent to you, or you get the ones because you're the active application. So you'll get Windows messages when the mouse is clicked, but only if you're the foreground window. So if you alt tab out, you won't get them. So there's all these messages, right? And they're in a queue. So what I have to do in my big loop is I have to have we got a message? If so, I will dispatch that message. I will translate that message. Blah blah. I'll explain that in a minute. Okay. And then we do the main game loop. Okay. I also have sleep. I need to explain sleep. I don't even know if it's strictly needed anymore. Sleep is a way of saying, hey, stop running my app. and see if anything else needs to run. And that is, it's kind of considered good housekeeping, I think. So there's a lot of programs running on Windows, and they're all trying to do stuff at the same time. And yeah, you've got like 8 cores on your PC and 16 threads maybe, but there may be 250 apps running. So they're all fighting. And sleep is a way of saying, I've got a little bit of spare time. I'm saying 1 millisecond, but it's not really, doesn't really hold to it. I'm saying if you want to interrupt my app, do so now. If you don't do that, your app can kind of thrash and use too much resources. Anyway, I think Windows, so many coders would slack and didn't do this that I think Windows forcibly interjects anyway. But that is the core loop. The main point I'm getting at, right, is that it's this. If you're thinking, I've used Unity, but where's the code for the start? It's here. It's a function called WinMain. Unity will be doing this for you, or Unreal, or whatever. Anyway, so that's that. Okay, there is another function that you kind of have to declare, and that's called like a Windows procedure, and that is the message processing stuff. I call it WndProc. I don't think you have to call it WndProc. Anyway, it doesn't matter. And this code up here, when we say like translate message, don't worry about it. Dispatch message. So that's saying peak messages, is there a message? If there is, get message means give me the message, please. This stuff down here is irrelevant because I do it here. And dispatch message says give it to the Windows procedure, the function that I have declared that will handle messages for me. And this is it, WndProc, right? It's a bit longer, but most of it's nonsense, and it only really does 1 or 2 really simple things. So every message that your Windows gets, you need to kind of process in some way. But there is a thing called the default window procedure down here. So if you don't want to do anything special with a message, it just falls through this switch statement down here and just carries on, right? But there are certain messages that I care about. One of which is WM destroy. That's kind of like Alt-Tab, not Alt-Tab, Alt-F4, or if you go into the task manager and end process, what happens is Windows does not stop your process running. That would be awful. Anything could happen. So it sends a message to your application saying WM destroy. We are destroying the window, so get your house in order, okay? And you'll notice that a lot of games will kind of intercept that, you know, and they'll pop up a message and kind of say, you sure you want to quit, kind of thing. So this is where you can do that, WM destroy. So I've got this function here, release resources, and that shuts down my engine. But before I do that, I call post quit message, which sends another message after this message, WM quit, and then the app actually shuts. So you kind of need that because you want to gracefully close stuff down, right? Maybe, for example, you might have like player progress in a certain level, and they suddenly go Alt F4, rage quit. You can still get in there and save. This is another one, WM active app. This is another message that is quite helpful. This is Alt Tab. This is saying we either Alt tabbed to you or from you. And you can do this thing where you cast one of the parameters that comes with a message to work out which one it is. I copy and paste this from every game because I can never remember. It doesn't matter. And I keep note of it. I've got a little Boolean flag there, has focus, because I want to know. This is the kind of place where you would stop the music, pause the music rather, or resume the music, for example, or all the sound effects. You know, I don't want someone to alt tab from my game and then hear a tractor beam while they were reading their email. I haven't coded that bit yet, but that's where you put it, and that's why you do that. And then you've got all of this, right? There's loads of stuff. Oh my God, Clef, it's so complex. Not really. All of these messages I then send somewhere else. So they are input. So keystroke down, keystroke up, a character has been sent, not the same thing. And the mouse button stuff. So mouse button up, mouse button down, right click, whether or not the mouse wheel has moved, blah, 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 blah. I send all of that to my own input manager, which handles them. Okay. Before I finish talking about that, I'm just going to mention this one, set cursor. I've intercepted, so you might think, well, that's what you're doing, Cliff. You've intercepted the set cursor message and then done nothing, and therefore it won't go through to the default Windows proc. I know. That's because, you know, I'm handling this stuff myself. Anyway, doesn't matter. So I'm using Windows messages here for input. Now, if you're a bit old school, you'll remember direct input and all of that kind of stuff. Just don't use it anymore. If you're using joysticks and stuff, I don't know. Maybe it's still useful. But I found that using the Windows messages for input, I don't think I use direct input anymore. Anyway, that's the Windows proc, right? I'm now going to talk about another function, and we'll kind of reference this. So if we go back here, you saw get game InitApp. That's a singleton, right? So if I go there, I'm just creating this game object once and always returning a pointer. Singletons are great. So I call that and I go into InitApp. So this is my InitApp function, right? There's quite a lot of, maybe not. I like small functions. If I can't fit it on the screen with 2 or 3 mouse scrolls, I think it's badly designed. I think that's a mess and I need to break stuff up. Anyway, so this is where we initialize everything in the game. I create some folders to save games and stuff like that. I initialize my own debug engine. You know, I load in preferences, blah, blah, blah. And when I've loaded in preferences as to like whether or not to be full screen and whether or not to be borderless and stuff like that, I then do something that, again, you probably don't know how to do if you haven't done this before. And that is I need to create a window. You might notice, although we're talking about a Windows strategy game, we haven't created a window yet. So there'd be nothing. Okay. Nothing would have happened. So I call this function create main window and I pass in loads of stuff. So some of this I've loaded from an ini file, and I'm calling that window ridiculous space barrels. So I don't know, is it actually running at the moment? Blah, 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 blah. Ah, balls. I forgot I set it full screen. Let's go back to normal. And okay, and quit. Let's try that again. I'm doing things like shit. A lot of people would edit all this out, but like I think it's quite helpful to. Oh no, hang on. I can't be borderless. That's a problem. I can't be full screen. What am I doing? Okay. Did that take? No, it didn't. I really need to fix this. There we go. At last. Right. Okay. Right. So you see up here, like on the Windows thing. Sorry about that. Ridiculous space barrels. That is literally just the string that I passed in here. Okay. And I'm going to talk briefly about this function where I actually create a window. So I keep it somewhere else because it's sort of part of my engine because it's quite boring code to write. So yeah, if we go here, this is it. Okay. This is the kind of arcane nonsense that you write once and then you copy and paste it in new games. It passes in all this stuff, blah, blah, blah. I do 2 things here. I load in an icon for the game, which is this load image stuff. And that's the icon that will be seen kind of when you're alt tabbing and stuff like that. I don't think I've actually created one yet for my game, and you can tell that because if you look up here, it's like the default app icon. You need to actively have an image that you tell Windows to associate with your window. And there's just a bunch of settings here. They're kind of a little bit obscure. Like one of them is like, yes, you can send double clicks to my window. I mean, why is that not the default? And there's a bunch of flags you have to set. You basically have to fill out this structure. this Windows structure, what's it called, Wind class X, with a load of stuff describing how you want your window to behave. And if it's in a window, it's something called overlapped. It doesn't matter. WS caption and sys menu. This is like that. You see that thing there? That's the sys menu. You can like not have that if you want. And a minimize box. I've got a minimize box here. I don't have a maximize box, you see. Impressive, because I haven't asked for one. And it's WS border. Although in Windows 11, it looks like they don't draw a border. So that's interesting. This is the kind of stuff where you're kind of saying whether or not it's going to be full screen and all that. Okay. And all of this really does, you fill out a structure, you register it as a class, just in case you want to create more of them. I mean, it's a bit silly. And then you call create window. And that's like always going to work. You're always going to get your window, right? But what you'll get is you'll get this. Now, well, this window will then be created, but you won't see it. Okay, which is very confusing. So if I just get rid of that and go back to where we were. So I've created a window. Woohoo! That's exciting. You then need to set focus to it, so it's the top window, so it's on top of all the other windows. That's set focus. You then need to call show window. Is it you'll never see it? Okay, you only ever need to do it once, right? And this window will then probably, I think it's by default black, just as empty black window, right? It's up to you to then fill that with your graphics engine of choice, OpenGL or DirectX, whatever you want. Okay, so then I'm initializing my 3D engine here. I'm loading in some textures, but not all of them yet. I have a thing called render splash screen. So let me just quit this and see if it loads on this window. I don't think it will. I'll just run my game. No, it doesn't. I can't move it quick enough, and it's defaulting to going over there because I'm being lazy. I draw like a splash screen, a simplified version of this that's just black and this logo, while I load in all the translations for my buttons, the background graphic, this graphic and that graphic, just so that something appears really fast. So a lot of people don't go to that trouble, but if you know what's going to be on your very first screen, just load that in, show the screen, and then load other stuff. Yeah, there'll be no mouse input and the user won't be able to click on anything for a quarter of a second or whatever, but it gives you immediate feedback, and I think that's really important and really good. And then I do a load of other stuff which we'll talk about when we talk about graphics, right? So this is my InitApp. The thing that I really wanted to mention though is that in InitApp I'm creating a window. Okay, so to summarize how you create a Windows game, let's see where we are. You need a function. Oh, so what's going on? WinMain. Yeah, okay. You need a function called WinMain. Okay, it has a loop where it handles messages. You start stuff. You init your app before your loop. Obviously, don't do it in the loop. You have another function which is called WndProc, and that handles any Windows messages. And then, where were we? Very confusing, isn't it? In the initialization, you create a window. And once you've created that window, let me just jump back, you then need to, you have to call update for some reason, and then called show window, right? You can then finish all your initializing, and then you're in your loop of your main game. Okay. Now, just to point something out, because I kind of forgot to mention it. You might be thinking that when I was talking about, it gets very confusing. When I was talking about WndProc and saying you have to have this and it gets the messages, you might be thinking, well, says who? How? Okay, that is when you call create main window, you pass in blah blah. There it is. There. It's the 1, 2, 3, 4, 5th argument that you pass in to create main window. So when you create that window, you're saying all messages pertaining to that window please send to this Windows procedure. No, that's not this app. There's nothing to stop you calling create window 4 or 5 times, creating 4 or 5 different windows, and they will have different Windows procedures to handle messages that get sent to individual windows. So don't forget, Windows is a windowed operating system. What it cares about is Windows and the interaction with them. You are one program, one process, but you can have many windows, and that's why it is arranged that way. Anyway, hopefully that makes some sense. I'm talking about this InitApp where we create a load of stuff. Okay, where's the game, Cliff? Okay, if you go back to the big loop, I keep getting it wrong, don't I? Here we are. Yeah, so here's our main loop. Here is the game, and here we are processing messages, blah 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 blah. Get game, GameProc, right? If you see these tomatoes show up now and then, you think, what's happening there? That's the icon for Visual Assist, which is a plugin that I have that changes the coloring of stuff, and it's just very handy, I find. So if I'm doing anything, you're thinking Visual Studio doesn't do this, that's Visual Assist. It's quite cool, and I've had it for so long I can't remember. Like, it will let me do some extra stuff here. I can't remember what is Visual Studio and what is Visual Assist. Anyway, here's the main loop. Get game. I have an object called GameProc. I'm calling it GameProc because of like WndProc, you know, processor or procedure, whatever. I'm very bad at sticking to conventions. I mean, that's basically get game process, right? So I'm going to talk a bit about that, because that's the main game loop, which is what everyone's kind of wants to know what it looks like. And the reason I think this might be interesting is if you do an online tutorial and you're making a really simple game, you will have a game loop, or if you've got a book on game programming, and it will describe your game loop. But I think what a lot of people who have never worked in the mainstream industry think is, yeah, sure, but like Fortnite has a different strategy, right? Or, you know, the Total War games aren't done. In other words, big projects with like 20 or 100 coders and huge companies involved and millions of lines of code, what do their game loops look like? Now, this isn't a game at that size, but I work for 2 big studios. I work for Elixir and Lionhead. Yeah, I mean, they kind of do the same thing, right? Ultimately, there's a loop, there's a function. Okay, it is no different. It's just there's a lot more stuff going on. So this is mine, right? And this is part of this game. You can see here it's inside Ridiculous Space Battles, and this is the stripped down version. This is where it gets a little bit complicated. This is where it becomes a little bit code architected, as they say. And you might sort of think, well, why isn't everything in here? I have a system that handles input, and I process that at the start of the frame. I do that because you can then respond to it within the frame, not the next frame. And I think that makes stuff a 60th of a second more responsive. I then process sounds as well. Could do that at the end. It really doesn't matter. I then call this other function here, which I'll explain in a minute, and then I draw the cursor. I think I actually let Windows draw the cursor. Yeah, Windows is drawing the cursor. Sometimes in my game you click something and you drag it, so I set that to be a special object, a drag object, and it's drawn at this point. Okay, and the reason I do that is it's then drawn on top of everything else until Windows comes in and draws the cursor so it looks right. So this is the general game loop, right? Get the input, process the sounds, do other stuff, draw a cursor. Okay, so what's going on here? This is a class of mine, game, like class game. And I don't want you to be offended by the fact that I keep changing my naming conventions over the last 20 years. Because there was a time where I put G in front of all of my engine stuff. So this is a derived class, right? So I have a base class, okay, which is G game. I haven't gone and looked at all this stuff before making this video, so I apologize for the mess of everything. Okay, so this stuff is actually, I strongly suspect, in my engine somewhere. Yeah, it is. Yeah, we're here. So, and this is because, like, when I make another game, I don't really need to redo this stuff. I mean, this is stuff that, you know, it just happens in a game. So there's a lot of functions in here that don't actually like do a lot of stuff. But some of it is kind of it's the same in every game. Okay, so what we've essentially got into is this GameProc. I'll show you how we got there again, because it's a little bit confusing, isn't it? Here we are in my game object, which runs the whole thing. That's where I initialize the game, shut down the game, and run the game. And we have derived from a base class called GGame, and we've jumped into that. Okay, so we're here. So this is what you probably think of as the main game loop, but it isn't. It's an extra level of complexity, but don't worry. Okay, so at this point, I just test that the graphics engine has still got control of the, you know, the screen or the window. If not, I need to recover the graphics engine. Okay, so if we've launched another app and it's stolen focus, and then, you know, I need to rebuild a load of textures and everything. If so, it's a little test here. See if that's okay, and then I do I process some input stuff. We'll talk about that another time because it's a whole topic. And then if be active, now you're thinking, where was that? Well, that is that little flag I talked about earlier that I set when we alt tab. Okay, because you could still run your game in the background. Okay, but I don't. So I've decided that only if oh no, hang on, sorry, no, it isn't. That's a different flag. This is actually set in the in WinMain, in the main function. Okay, so if be active isn't the case, then we're shutting down. Okay, so yeah, we're testing whether or not we've still got control of like the graphics card. We're processing input, and then we're in here. Okay, this is DirectX stuff. So it's pretty much the same with any API, but it's like begin render. In other words, tell the card we're ready to start drawing stuff for this frame. I then do this. I'll explain in a minute. Then we end render, and then we flip. So flipping is like back buffer stuff. So it could be a copy, or it could be just a pointer change. But it's basically, this is like your vsync stuff is there. Okay. So anyway, the important bit is here. Now you might expect to see, because we're now in the loop, right? You might expect to see all of the code that controls drawing planets and spaceships and asteroids and everything, right? I don't do that. I have a system of different like managers that control my game depending what mode we're in. And I just need to explain what I mean. So I'll launch the game and I'll click on some stuff. So this is a system called the main menu. This is another system for the research screen. This is a system for the choose level. This is a system for the deployment screen. And then the meat and potatoes of it is that this and all its like hilarious complexity is the actual game. Now, if I pop a window up, that's all contained within it. This is like the game mode. Okay, so currently we are in game mode battle. I'll just end it for now. Okay, so what I have is all of my systems in the game, all of my game modes are derived from a single base class. Okay, so if we look, let me try and find one. The deployment screen is a perfect one. Okay, so I've got GUI deployment mode, and it is derived from my game mode base class. Some of you will be going, yeah, cool. Some of you will be going, what the hell are you on about? Why? Okay, the reason is that it is very good to compartmentalize your code into chunky systems. Okay, if you're writing a small little indie game, you don't need to worry about this. But if you're doing a big sprawling game, things get out of hand really quickly. So if you look over here on the left hand side, all of the code for the deployment screen, the GUI code, not the simulation code, is in this folder here. Okay, and it has subfolders, and some of them probably have subfolders. There's a lot. But all of that code there is for the deployment screen, and it is very specific to the deployment screen. Okay, when you're working on a really big project, you don't want to be scrolling and scrolling and scrolling and scrolling and scrolling and going, where's the code that controls the thing? You really need to be organized. So all of the deployment user interface is in here somewhere. If we're deploying in a campaign game, it'll be in there, or the campaign specific stuff will be in there. The orders pop-up is quite complicated, so it's got its own folder. And all those windows that I create on that deployment screen are within here, yeah? So what that means is I've created a bunch of different modes. The battle is also one. So if I've been really slack and not put GUI battle up there, maybe I have. That's just shocking. I know it's there somewhere, or am I just going blind? Let's go to another one. Yeah, okay, research. Okay, research UI. Originally, research was called store. I need to rename it. But there you go. Look, here's the research screen, store. It derives from Game mode. And if I go back here, deployment screen and game mode, there's loads of them. Okay. And that means I stick to an exact series of functions. So if I right click in the deployment screen, I know I'm going to end up here. If I right click in the research screen, where have you gone? I know I'm going to end up here. And because they're the same and they're derived from the same base class, what that means is if I go back into the GameProc stuff, I can call functions without caring. I don't need to care. Okay. And one of the most obvious ones is draw. Okay. So this is where we're drawing the screen because we're inside that begin and end render. So here I'm just saying whatever the current game mode is, I've appointed to it. Draw. So this is the main game loop, regardless of what's going on the screen. You could be in the store, you could be in deployment, you could be in the middle of a battle, but the same principles apply. And you should do this because the reason for it is I have all this code here, right, to check has the game been quit? Do I need to recover the graphics engine? Stuff like that. I need to process input. There's no way I can forget. So there's no way I will have a crash because we lost access to the video card in the deployment screen and I forgot to check there. Okay, when you have a bug like that, where the game will crash if you like alt tab, but only if you're in a certain window at the time, that's because they didn't do this. Okay, if you set things out in a more organized way, then it's always going to be processed the same way. You learn this the hard way. Okay. So hopefully that makes sense. Let me just check my list of other stuff. And how long I got? No, it's fine. It's fine. Okay, so this is a long-winded way of me explaining that. Okay, so the current game mode would be whatever, and we'll click on draw. So let's assume we're in. But let's assume we're in the fun stuff, right? Yeah, GUI game. That shouldn't be there. That should be in another folder, really. Shouldn't it? Yeah. Okay. So if we go, so in the middle of a battle, we'll end up in here, right? GUI game draw. Don't worry about this debug, memory check nonsense. So this has been a very long way of describing the game loop, and you're probably thinking, but I still don't see the game. I still don't see where any of the code is for the game. Where's the spaceships, etc. It's here. So this is if we're in a battle. This is the function that gets called. And you know I said I hate long functions. Yeah, it's the longest one in the game, probably. Yeah, almost certainly. A lot of it is profiling stuff. But this is it. This is the game. This is what's drawn. There's no trade secrets here. Good luck making sense of it. I'm not going to go through everything. The reason it looks... like there's a lot going on here is that probably what you expect to see is code that says draw the background, draw asteroids, draw ships, draw particles, maybe do some clever effects, end. And that is what I've got here. but there's a lot of it, okay, and B, there's a lot of profiling stuff, and some of it is multi-threaded, which is a whole nother video. Okay, so just to point out a few little things here in that. Concurrency marker, right? This is a macro that I'm using. Well, I'll do a whole video on profiling and concurrency. When I talk about concurrency, this is when you're executing two lots of stuff at the same time. It is very complicated, but it's lovely. If you're not doing concurrency stuff, if you're not doing multi-threading, you're using about 12% optimistically of the CPU. So what are you doing? It's silly. If you want to push it, use everything. So I have some stuff like concurrency marker here and this span thing here, and I think this is for the concurrency visualizer in Visual Studio, and it just, when I look at all the debugging stuff, I'll see these little marks. I'll see a little marker showing me what function I'm in, and that way you could visually look at profiling and go, asteroids take a long time, or you can say everyone's waiting for the asteroids to finish multi-threading wise, and it helps. So there's a lot of that, and this is other stuff. D3D perf begin event. I think that might be for picks. I use basically every profiler, so that is another way of sort of going, hey, put a marker here. So when I look at a DirectX API capture of a frame, which will be thousands of lines of code, I can sort of go, okay, so this is plumes, and then we called 600 API functions inside this. That's why I've got all of these lines. Okay, so more than 2/3 of the lines are just for profilers. Okay, but basically, I'm now going to talk about my general approach to this, which I think might be interesting. If I was to take away all the profiling, what you would see here is a bunch of calls like this. Well, let's go with a simple one. Yeah, okay, that's relatively simple. So sim get bullet manager draw. Okay, everything is, look, sim get this draw, sim get that draw, sim get this other thing draw. These are all like managers in my game, and by doing this I control the draw order, and I don't have anything can be at any level to make things a lot simpler for me. So like all the plasma torpedoes that are beneath ships are drawn here, the ships are then drawn, all the bullets are then drawn, missiles are drawn here. I think that is above, yeah, so this is missiles drawn above ships, that would be missiles drawn below ships, and therefore it looks like I've got a proper 3D thing with stuff going over and under, but I don't. They're just set into chunks. So I control the draw order of all this stuff. For my game, this works. It may not work for you. You may need a more kind of anything can have any Z order thing. But this game is done with what we used to call the painter's algorithm. So the painter's algorithm is literally like you're painting a picture. So you draw the background, you draw the sky, and then you draw the mountains, and then you draw the houses, and then you draw the people in front of the houses. Okay, you can get a lot of what they call overdraw, where you've drawn the same pixel many times that way. That's the downside. The upside is it's very simple, and it allows for really nice blurry compositing, so you don't get hard chunks. If what you're drawing is a bunch of very high poly objects with crisp edges, you can use Z buffers and draw things in any order you want, and there's reasons for doing that. I'll talk about that at some point. But for me, this system works. I use painter's algorithm, so I draw that whole big nebula backdrop. Let's launch the game again. So let's get into a battle, because we're talking about battles. Let's get into a big battle. Yay. Yeah, there's a lot going on. I'll just speed ahead to get some stuff happening. Yeah, let's stop there. Yeah, so I'm drawing that nebula, that red thing, and then I'm drawing that planet, and then I'm drawing ships, and then I'm drawing shields on top of ships, and then I'm drawing a million billion other things, and then I'm drawing the UI. I can toggle the UI off, so it's all of this stuff. and there's like overlays that I'm also drawing on top. It is nowhere near this simple, okay? Because what I'm doing, I actually have other off-screen render targets. I'm drawing light maps separately, and then I'm drawing distortion, and I'll talk about it another time. It's a lot more complicated than that. But the thing that I wanted to draw attention to is the managers thing. So let's go back to what one was I talking about? Pick one that's quite simple, mine manager. So this is where I draw the mines. So if I go into that, so I've got code here. If I flip to the class, so this is a manager that handles all of the mines that have been dropped in the game. I think this is probably the last thing I'll talk about in this video because I don't want to go on for hours. And this is a system that I use a lot. I don't think I mentioned it in the last video, but even if I did, it's worth reiterating. So I use this thing called a singleton. I mentioned it earlier. And this is a global function. The whole of the game can see that bit, just that bit. Okay, so the whole of the game has access to call sim get mine manager. If you want to do stuff with mines, you call sim get mine manager. And because this is a static object in here, the first time you call this, it creates one. And then every other call to this function, you'll just get the same one. I love that pattern. It's called a singleton. You don't have control. What everyone says is singletons. No, you have no idea in what order they are released. And I sort of think, dude, I don't trust Windows to decide the order. When I close down my app, I go through all my managers and I call my own release function on them. That's how I rock. So you'll notice the destructor is empty. Nothing happens in it. I am relying on me remembering, and I do, to call this. So I do have control over the order. Funnily enough, I got one very negative comment on the last video, basically saying, you don't know what you're doing. You're declaring constructors and there's nothing in them. And I know what I'm doing. The reason I've got this is I can put a breakpoint on it. That's why it's there. Yeah, it will compile away to nothing in release build, I know. But if I'm sort of thinking, hang on, there's a bug, it must be when the mine manager is destroyed. And when is that? Because I have no control. You can put a breakpoint on there and see it happen. That's why I do it. Sometimes you'll come, when I'm scrolling through code, you'll see empty functions. That's why. Now, obviously, when debugging, I could then declare it and stick it in. But honestly, like, you know, it's not exactly hard. You can just like right click and go, oh, I've already got it. But like you can right click and go create this function and it'll create an empty one for you. So I do that because like I like to have that control. Anyway, so that's a singleton. Okay, I have found that contrary to what many documents will tell you, that yes, you do need to declare these, force these to be in line. Sometimes Visual Studio screws that up. I've profiled it, trust me. Okay, so I forced this to be in line, which is a way of speeding it up. Okay, so yeah, there's an object called a mine manager and it handles everything to do with mines, and here they all are. I have a little class that's private that I only need internally here, but the thing that really matters here is I do these things different ways so much it's a bit inconsistent. But ignore a lot of this and just concentrate on this. So I have a list of mines. So in the game, ships will drop mines, mines will explode, other ships will drop more mines. So I need a list, not a vector or an array, because things are being deleted in the middle of it. Now, you really should learn how to code a container, a linked list. It's not that hard. It'll take you like a day to get your head around it, and it's a bit fiddly, but it's important to know how a linked list works. They're not the fastest things in the world because they can become scattered all over the place. There are ways of reserving capacity and everything. But it's one of those things, like it's always worth learning how to code a linked list and then use someone else's. Specifically, I use STL for this. That's the STD, whatever. I really only use STL because I use the strings some places, and I use vectors and lists I don't even use maps or anything like that. But I find it quite helpful. So if we find, like, when I'm drawing stuff, there's just a loop here, a for loop that goes through all of, like, the UIs, which I've got a list for separately. Just don't even go there. And, you know, I'm calling draw on it. So this is a way of me drawing all of the mines in one go. And the reason I'm kind of doing that is I'm not drawing them individually. All of their draws get collected into a vertex buffer. So if there are, like, 500 mines on the screen, it's one draw call, which would be here, draw copied in lazy. It doesn't matter. So that's why I like my painter's algorithm, because if I'm drawing all the mines together, then I have not as many draw calls as I would otherwise. Not such a big deal with modern versions of DirectX, but with DirectX 9, you don't want to be doing like 1,000 draw calls. That will just crush your graphics card on DirectX 9. So it's the, you know, it's the way I do it. I use managers a lot. Okay, so we're in the mine manager, but there's loads. If we go to, like, the missile manager, again, it's a bit more complicated than this profiling stuff, but it's basically doing a for loop where it calls draws. Yeah, and the basic structure is the same. I haven't got a base class for these managers, basically because they share nothing in common, really, unlike the game modes. So I do that a lot. The last thing I'm going to mention is debug and release build. I was running this in release earlier, but I tend to code in a debug build. Debug builds are slower, but they catch a lot of errors that you wouldn't get otherwise. I think it is good practice to spend a lot of time working on your game in debug build, and also very often run it in release build. You get bugs in release that you don't get in debug, and the reason for that is debug initializes a lot of stuff to be harmless, to be null or zero. I use pointers an enormous amount, and sometimes I will be checking. I don't want to hunt around for a version, but sometimes I will, for example, there will be something like a mine, yeah, and it will have a user interface object and a pointer to that object, and I won't bother creating the user interface until I have to draw the mine, because in a huge battle, ships will drop mines, other ships will go over them and explode, and that'll all happen off screen while you're looking at something else. So why waste the processing on creating the user interface object? So I could do it lazily, for example, and do it at the last minute. The way I would normally do that is the pointer to the user interface object would be initially null, and if I come across, and if I'm about to draw it, and I haven't created it, I'll probably have a flag for that. Or I would check that, like, is the user interface pointer null? If it is null, it's like, oh, I haven't created it yet, so I will then create it and we're fine. If you forget to set that initial pointer to null, then that will work fine in debug mode. But in release mode, the value of that pointer will be whatever random contents there are in memory when you start the game. So then you will go, oh, I do have a user interface for the mine. I will run draw on that and it will crash. And it will only crash in release build, not in debug. Generally speaking, if your game crashes in release and not in debug, you have an uninitialized variable. It is the big thing. The last thing I'm going to say is they tell you, the system tells you that running release build is just like the final version of your game. No, it isn't, because there is a debugger present and it's hooked in. You can hit a breakpoint in release, okay? A lot of the variables you look at will be wrong, misleading, or flat out garbage, but you can hit a breakpoint in release build and look at stuff. And the reason you can do that is the debugger is hooked into your game. It's not much use, but it's there. And stuff happens differently when there is a debugger and you launch on the IDE. If you are about to release your game and you want to be absolutely sure there are no bugs, don't just play it a lot in release build. Play it outside the IDE. Shut the IDE. Upload a build to Steam privately. Download it from Steam, because they also do like virus checking, stuff like that. Get the actual executable version. that the customer is going to run that and play it a lot, and rarely, but sometimes there'll be a crash that's only there, and that is your last defense against shipping with a really bad bug that you didn't know. So code a bit in debug, code a little bit in release just to check it all still works, but also very occasionally run your game outside the IDE, and also obviously run it on other PCs. If you're lucky enough to have a shit old laptop, run it on that. That's the best test. Anyway, that's about the same length as the previous video. Thank you for getting this far and watching this. Let me know what is confusing and what isn't, or what I just hand waved away and you sort of think, well, explain that a bit more. Or let me know what topics I've kind of alluded to, like sort of profiling and multi-threading, or the actual rendering, or some of the DirectX stuff I do to make my game look a bit cool. I don't know what people are interested in. I haven't really mentioned how I handle input, apart from just to say I use messages. Yeah, so let me know. I do read all the comments. I'm not replying to them all because there's a lot. But anyway, thank you for watching this, and yeah, like and subscribe. You can always add my game to your Steam wish list if you feel like it. Anyway, yeah, and I'll do another video at some point. Thank you.